Hello, I guess Falcha Huladunya. Hello and welcome to Slip into Ruby, part 2. Correct me if I'm wrong, but I think last time we did this, which would have been 2 weeks ago, I got to the end of Data Manager, I believe. So we will kick off today with Scene Manager. This is the module that handles scene transitions. Wait, did I do Scene Manager already? I don't think I did. No, I'm pretty sure I didn't. Yeah, because I would have covered that. So, yeah, so this handles the scene classes. So your map, your item screen, battle scene, the equipment screen, all these are separate scenes in RPG Maker, and Scene Manager is the class that handles all of the stuff that goes on in them. So we've got, first of all, setting a few module instance variables. So we've got one called scene, which we're setting to nil. That holds the current scene object. We've got stack, which is initialized as an empty array. That's a stack for when you want to go back to a previous scene. So that kind of holds the kind of hierarchy of scenes that preceded the current one. And then we also have this background underscore bitmap is set to nil, and that will store the background bitmap, which we'll see in a second. So we've got this self.run here, and if I go down to the main process, you can see here that your main thing is just calling scenemanager.run, and that's kind of what starts off the whole engine effectively, and that calls this here. So the first thing we do is call datamanager.init, and if we go back to data manager, which we looked at 2 weeks ago, that just calls this method here, which sets your last save file index to 0, loads a database, creates the game objects, and sets up the battle test if you're in battle test mode. Then we call the setup underscore MIDI method of the audio module. If use MIDI is true, and that is this method here, which just returns data underscore system dot opt underscore use underscore MIDI, which actually maps to this checkbox here in options in the system tab of the database. So it will be true if that box is checked and false if not. We set the scene module instance variable to a new instance of first underscore scene underscore class, and if we look at that, it will be scene battle if btest is true and scene title otherwise. Reason being, btest is a global variable that determines whether you are currently in the battle test or test play or a deployed project. So if you're doing a battle test, it sticks you straight into battle, and if not, it takes you to the title screen. And then finally, we are calling the main method of the scene object while there is one there, so while this is not nil. And if we yeah, so main will be determined by the individual scene classes, as you'll see when we get to scene base and the like, but that'll be a while yet. So yeah, that's your basic run. There is a method called self.scene. It's just a wrapper method that gives you the value of the underlying scene instance variable. So other classes can refer to that without having to access that directly. In Ruby, instance variables are protected unless you write a wrapper method for them like this, or set them to attr reader or accessor, which is a read and a write. We also have self.scene underscore is question mark method. This takes as a parameter a scene class and just returns whether the current scene is an instance of that class. So you could, for example, do that in a script, and it will return true if you're currently on the map and false otherwise. So we've got two methods for switching between scenes. There is the goTo method, which takes a scene class parameter and sets the current scene object to a new instance of that class. Or there is the call method, which does the same thing, but before doing that pushes the current scene to the stack. And that's how we kind of get this hierarchy of scenes. We've got this return method that returns to the caller, so it just sets scene to stack.pop. In arrays, the pop method takes the last element of the array, removes it from the array, and returns it. So this basically takes whatever the last element of stack is, pops it into this variable here, and it will no longer be in the array. So it's kind of a last in, first out sort of thing. Then we have self.clear, which just clears the stack. That sets the stack array back to a blank array. We've got self.exit, which sets scene to nil. And if we remember back here, where we're calling scene.main while scene, that's an infinite loop, but it only loops until scene is no longer holding data. And when we call exit, by setting that to nil, we break that loop and it stops processing the scene. Also got this self.snapshot_for_background method. What that does is it creates a snapshot to use as the background, and I'll just demonstrate that if cool. So you can see here I've got this map that you can run around on, and if I go to the menu, you can see that behind the map menu, it's basically like slightly blurred the map and use that as a background, but it's not you're not seeing the actual map, you're seeing a snapshot of it that's been blurred. I'm not going to show you how that works. So first of all, we call background bitmaps dispose method if it is not nil. Reason being that we want to make sure any existing bitmap is disposed before we allocate memory to a new one. Then we set background bitmap to the result of calling the snap to bitmap method of the graphics module, which isn't exposed in the script editor, but basically it takes a snapshot of whatever's currently showing on the screen and converts it into a bitmap object that you can then store in variables. And then we're calling the blur method on background bitmap to blur it slightly. Now remember where I showed you that menu thing, it was slightly blurred. If I were to comment that line out, and go back to the thing here, go into the menu, you can see there that it's not actually blurring anymore because I've taken that line out. There's no real rhyme or reason to blurring the background, it just kind of makes it look like it's lost focus and it's now focusing in on the stuff that the scene is showing. It's kind of more of a visual thing than anything else. And then we have a self.background bitmap method. That's just a wrapper method to get the underlying background underscore bitmap instance variable. And that's all it really is to Scenemanager. It's a very lightweight class. Most of the heavy lifting of that is done in the main method and methods that are called by it. So Scenemanager doesn't really need to do an awful lot of heavy lifting, but what it does do does a lot of work. Conversely, however, we have Battle Manager, which, as you can see from the scroll bar, is quite a bit larger. This is the module that manages progress in battle. As you know, in an RPG, the battle system is one of the more important aspects of it. So, first of all, as with Scenemanager, oh wait, no, that one doesn't have a setup. Never mind. So we've got this setup method. And it takes 3 parameters. a troop ID, which will be an integer denoting the ID of a troop, which, as you can see in the database, corresponds to one of these troops here. We have can underscore escape, which is a boolean. It defaults to true if you don't provide it, and can underscore lose defaults to false if you don't provide it. Can escape is a flag that denotes whether the party is able to escape from the battle or not. Can lose is a flag that denotes whether the party will continue. It's basically like, say you have a boss battle that you're meant to lose, and you want something to happen after that. Instead of going to a game over, then you would set this to true, and there will be a branch in the event that starts the battle, and you can do stuff after it. It won't go to the game over screen if you lose. So the first thing we're doing in setup is calling init underscore members, which is this method here. So we're setting several instance variables here. We've got one called phase that's being set to the symbol init. If you remember from 2 weeks ago, symbols are just like strings, but only one copy of them exists in memory. So anytime I refer to this colon init, that it will refer to the same point in memory, rather than if it were in it as a string, it would create a new copy of that every time it was referenced. We've got can escape equals false. Which I don't know why they kind of defaulted that to true there. I don't know. So yes, can escape to false, can lose to false. This event underscore proc is being set to nil, but it will hold an event callback. A callback is basically when you have a method or function that will be called in response to something happening. And we'll see that when we look at things like the player choice event command. Makes quite heavy use of that. Preemptive gets set to false. That's a flag that denotes whether the battle is a preemptive attack or not. Same with surprise, setting that to false. That's a flag that denotes whether the party was surprise attacked by the enemy. We've got this actor underscore index being set to -1. That will hold the ID of the actor for whom you are entering commands. Action underscore forced being set to nil. That will store an action object for when you are forcing a particular battler to take a particular action. We've got map underscore Bgm set to nil. That will store the Bgm object for pre-battle music. Map BGS set to nil. It's the same for background sounds. Then we've got this action battlers array, and it's being dimensioned as an empty array to begin with, and that will hold the action order list, or the order of the battlers in order of when they will actually get their turn. So following that, we call game underscore troops setup method, passing in the troop ID. You can see there that that corresponds to this class here, which we are not yet at, but it basically sets up the troop using the troop ID that was passed in. Then we're setting can escape to the passed in value, so that will either be true if no value was passed, or false if you passed false to it. Same with can lose, and then we call make escape ratio, which if we scroll down a bit, we can see here. So we're setting an instance variable called escape underscore ratio, and we're setting it to using order of operations. First of all, we take 1.0 times gametroop.ag divided by gameparty.ag. Again, these correspond to the game underscore troop and game underscore party classes, which we'll look at late, probably quite a while from now. But basically, the .ag method gets the average agility of among every member in the unit. So that will get the average agility of the enemy troop, the average agility of the party, divide the troops of average agility by the parties, and then multiply that by 1 as a floating point number, which will give you a floating point result. And then we're taking 1.5 minus that value, and that will give you an escape ratio. So you can see that that's your escape success probability. And what that basically means is that the higher your party's agility is in relation to the enemies, the easier it will be for you to escape from battle, is all that does really. So what else have we got? We've got an on_encounter method. So that is a method that's processed when a battle happens. So we're setting the preemptive flag to whether a random number is less than rate preemptive. Rand in will give you a random number between 0 and 1. So rate preemptive is just a wrapper method, gets the probability of a preemptive attack by calling the same method of the same name in game party, passing in the average agility of the troop. And again, when we get to that point, I'll kind of tie that back to this. And then we're doing the same for a surprise. So that is set to whether the random number between 0 and 1 is less than the result of calling rate surprise, which, as we can see here, just calls game party's rate surprise method, passing in the troops' agility, average agility even. But we're also making sure that the preemptive flag is false, because if it's a preemptive attack, it can't be a surprise attack. Fairly simple, really. We have a save Bgm and Pgs method, which just sets the map Bgm instance variable to the last method of the Bgm property of the RPG module, and same with map Pgs. So RPG is kind of a high-level module under which basically all of the objects fall. See if it'll show the help file. It will not. That's fine. It's basically a module containing all of the data structures. So it contains actor, animation, animation frame, animation timing, armor, BGM, BGS, like everything that is represented by an object comes under this RPG module umbrella. And then as an RPG BGM, the last method gets the BGM that is currently playing. It saves the current playback position, and if no BGM is playing, it returns an empty object, and same with BGS. So it just takes whatever is currently playing and stores it in this instance variable. So then we've got this play battle BGM method. So that goes to game system .battle BGM and calls its play method, and then we are calling the stop method of the RPG BGS, which stops the currently playing background sound. So when we get to the game system class, we'll see the battle BGM method. Same with the battle end ME. I don't actually know what ME stands for, but they're basically like shorter pieces of music that only play once, like the victory theme, game over theme, things like that. They're stored separately, so they're treated as a different kind of audio file, even though they are still GG files, the same as music they don't loop. And that just calls the method of the same name in game system, and then calls that object's play method, which plays that audio file. We have replay BGM and PGS, which resume the ones that were playing before. So we take this instance variable, which I would say when these were saved, it was stored in here, and we call the replay method on that, which I believe replays the BGM that was obtained by last, and I think that restarts it at the same position as it stopped when it was saved. Unless you're in a battle test, because this is only really used for going back to the map after battle, and you don't do that in battle tests, so there's no need to. And then, again, same with the background sound. And we've got a few methods determining where what phase we are currently in the battle turn. So we've got in turn question mark. That returns whether the phase is equal to the symbol turn. We've got turn underscore end question mark. That checks whether the phase is equal to the symbol turn end. We can check whether the battle is aborting, which will happen if, say, there's a timer running and it runs out, or if you manually abort battle in a script. That checks whether the phase is equal to the symbol aborting. We've got a wrapper method for whether the party can escape from battle, so can underscore escape question mark, which just returns the value of the can escape flag. We've got a self.actor method, which gets the actor for whom a command is being entered. So if the actor index instance variable has a value greater than or equal to 0, then we will return the that index from game party's members array. Otherwise, we return nil. So game party's members is just an array of all of the indexes of the actors who are currently in the party. So we're just looking for whichever member corresponds to the actor index variable. Then we also have clear actor, which sets the actor index to -1. You'll see that quite a lot. -1 is generally used for clearing things out, especially for arrays where 0 is the first element and you can't use it as a neutral value. We have a next command method, which gets us to the next command input. So we have a begin and end block. So that is kind of it's just a way of giving us a block of code that we can run repeatedly under some circumstances, which we will see in a bit. So if the actor method returns false, which it will if it's nil, because that's a falsy value, or the actor's next command method returns false. This will only be evaluated if actor does contain a value because of short-circuiting. So if this returns false, this part won't even be looked at. So we need to check that there's an actor there first before we check this method. Otherwise, if there's no actor there, it will give us an error because we're trying to call a method of an object that doesn't exist. But yeah, if that is the case, then we add 1 to actor index, and we return false if actor index is greater than or equal to game party.members.size, and that will give us the number of members in the party. So if you had, say, 3 characters, then size would return 3, and then it would return false if actor index were greater than or equal to 3. We end this block until actor.inputable returns true. So that will just run over and over again until that returns true. And we'll see that when we go into game actor, which is the class that contains that method. And after that loop, we return true because there are no actors left to get commands for. And then to do the reverse of that, to get the prior command, we're calling the prior command method instead of next command. We're reducing the index by 1 instead of adding 1 to it, returning false if the index is less than 0, and the rest is just the same. We have a method for setting the event proc instance variable. So event proc equals takes as its parameter callback method and just sets the event proc instance variable to the value that was passed to it. Then we have a method for setting the method wait for message instance variable, which I don't think we referred to up here. So that takes as its parameter a method, same as, well, it's a method, not a proc. and that sets this instance variable here, this method wait for message, to the method that was passed to it. We have a wait for message method, which calls the method stored in this variable here if there is one. I'll explain more about that when we come to the point in time where that's actually being used, because a lot of these seem very abstract and confusing right now. It's just because they haven't yet come into a use case later in the script. And I could kind of jump back and forth looking for all the places where they're used, but it's probably best to just wait, kind of give an overview of them just now, and then come back to them when we get to the points where they are actually being called. So we have a method for when the battle starts. When that happens, we are incrementing the battle count property of game system, just adding one to it. We're calling game parties on battle start event method. Then we're calling game troops on battle start event method. So that'll just call the respective method in each of those classes to set up whatever starting stuff needs to be done for the party and the troops. Then we've got a loop here. So game troop dot enemy underscore names. That gives us an array of the names of the enemies in the troop. And then we're calling a dot each, which will apply this block of code to all of the array elements, and internally we are referring to the current element using the identifier name. So anytime name is referred to here, it's referring to whatever the currently iterating element of the array is. So we're calling game messages add method, which allows us to add a line of text to the message box. We're calling sprintf and passing in vocab emerge and the name. So if we remember, we have looked at this before, I think, a couple of weeks ago, but sprintf basically formats a string for printing. And if we go back to vocab and look up emerge, we've got %s emerged. So %s is a placeholder that when we call sprintf, that will be replaced by the first argument that's passed to it, and it will be a string. And we can see here that we're taking that. So the %s will be replaced with the enemy name. So it will say enemy name emerged. And it'll do that for each different enemy that's in the troop. Now, if preemptive flag is true, meaning it's a preemptive attack, then we're also adding the game message using vocab preemptive and game party.name. And if we look at preemptive, you see there it's %s got the upper hand. And although we haven't seen it yet, the party's name method basically creates a string from the party leader '(s) party. So if your party leader is Harold, for instance, that method will return Harold's party, and that will thingy there. Well, I'm pretty sure you can denote that in the oh no, it's wasn't until MV that you were able to actually set all of the term strings. That's fine. Else if, so if it's not a preemptive, else if it's a surprise attack, we're doing the same game message.add, but we're using vocab.surprise, vocab ::surprise instead, and still using game party.name. And you can see surprise there, %s was surprised. So if that happens, again, it would be like Harold's party was surprised, for example. And at the end of that, we are calling wait for message, which we've just looked at there. It just calls the message wait method. And again, I'll explain that in a bit more detail once we get to that point. So we've got this self.abort method, which just sets the phase to the symbol aborting. And again, if we look back here, that means that this method here would end up returning true. We have a judge win-loss method, which determines whether the party won or lost the battle. So if phase is not nil, we'll go back here. Remember, phase started off as init. I don't know that it ever does actually become nil. Maybe it does. But yeah. So if phase, we return the result of process_abort if gameparty.members.empty returns true. The empty method checks whether an array has no elements in it. So if members returns true for empty, it means we don't have any party members. So we look at process_abort, and that just calls the replay Bgm and Pgs method, calls Scenemanager.return, which will return us to the scene that we were in before the battle scene, calls the battle_end method, passing in 1. So if we look at battle end, the argument we're passing there is for the result parameter, and we can see from the comment there that a result of 0 is a win, a result of 1 is an escape, and 2 is a loss. So when we do the process_abort, we're basically considering it an escape. We're setting phase to nil. Okay, yeah, so that's where we get the checking for phase. If there is an event proc present, we will call that method, passing in the result, and then we call the onBattleEnd methods of both the party and the troop. And if we're in a battle test, we call Scenemanager.exit because we now want to close the game entirely. Obviously, we don't want to do that if we're not in battle test, which is why we've got that check. And then we are returning true. Which will return true to this method, so whatever called that will get a true back. If that does not happen, so if gameparty.members.empty is false, then we go to the next line and return process_defeat. If gameparty's allDead method returns true. AllDead is a method that will only return true if all of the members of the party have died. And obviously if that happens, the party has been defeated. So we go to this method here, process_defeat. So we're calling gameMessage.add, again using sprintf, using vocab, : defeat, passing in the party's name. And again, if we go back to here and look at defeat, it's %s was defeated, so that will end up being something like Harold's party was defeated. We call wait for message, which again going back here just calls the method wait for message method. If can lose is true, meaning that the party is able to lose without getting a game over, then we call the revive battle members method, which look at down here. That just goes through each member of battle members, which gives us an array of just the party members who participate in battle. We're using the iteration variable actor here and returning or setting actor's HP to 1 if the actor is dead. So that will just set all party members to have 1 HP. Then we replay the Bgm and Pgs and call Scenemanager.return, which returns us to the previous scene, which will more than likely be the map. Otherwise, if can lose is false, that means that the party cannot lose without getting a game over, so we're just calling Scenemanager.goto and passing in scene game over. And if we look at goto here, it just sets the scene to a new instance of that scene. There's no stack involved, it just goes to game over. Reason being that after game over, you will not be going anywhere else besides possibly the title screen or closing the game. And then we call battle end, passing in 2, and again, if we look down here, a 2 is a loss. And then we return true because we were indeed defeated, and that returns true to judge win loss, and that will return true to whatever called that. If that is not the case, if the game party is not all dead, then we check if the game troop are all dead, and that means that we've defeated all of the enemies in the troop, and if that is the case, we return process_victory. So this plays the battle end ME, which will usually be a victory theme of some sort. Yeah, so yeah, just this one here, so just calls the battle end ME file. We replay Bgm and Pgs, which will give us back the whatever the previous music and background sounds were. We call GameMessage.add using an sprintf again, passing in vocab victory and the party's name, and if we go and look at that, we can see that it's much the same as defeat, but it says was victorious instead of was defeated, and that's what will show in the battle in the message window. We then call display_exp. So here, if the game troop's exp total is greater than 0, meaning that the troop is awarding 1 or more experience, we are setting text to the formatted string vocab obtain exp, putting exp total from game troop in as the value, and if we look at obtain exp, it's %s exp received. So that will just say like 100x received or 10x received or something like that. And then we're adding the string dot plus the text. So that's backslash, meaning that that's an escaped dot. What does that do exactly? I can't actually remember. Let me just very quickly try something and see. I think it's just a new line. Yeah, that'll be what it is. It's doing a new line. Or possibly, oh no, the /dot. That's a control code that causes a short wait, isn't it? Yeah, waits a quarter of a second, so it just gives you a small pause. And then the text, and that's why it takes a little second for it to display. That's fine, cool. Where was I? Yeah, then we call gain gold. So if the game troop's gold total is greater than 0, meaning that the troop is going to give you 1 or more gold, we're setting text to the formatted string from vocab obtain gold, passing in the gold total for game troop. You can see here that's just %s/g found. /g will be replaced in the text with whatever the currency is, and you can see in the terms that the currency is. Can you set the currency in VXS? In system? Yeah, that's just the currency unit, so that'll be whatever is set here. Then we're adding to the game message that quarter-second wait plus the text, and then we call game parties gain gold method, passing in the gold total. and then we wait for a message. Mainly because we don't want to continue with the thing after the gold has been displayed. Yeah, I'm pretty sure that when you win a battle, so if I do that and say that I drop up motion, I'm just going to double check this, make sure I am being factually correct. Yeah, so it shows you the experience in gold. The wait for message means that I have to input a key, press a key to continue, and then it shows the items, and then it waits for a message again. That's pretty much what I thought. So going back to here, then we call gain drop items. So that's this one here. So we're calling game troops make drop items method, which gives us a list of items that the enemies in the troop can drop, going through each one using the iteration variable item. We're calling game parties gain item method, passing in the item as the item we're gaining and 1 as the quantity, which we'll see when we get to game party. And then we're adding a game message using sprintf. Using vocab, obtain item with the item's name. And if we look at obtain item, it's just %s found, so that will be replaced with the name of the item that you're gaining. And then we wait for a message, so that you have to press a key to continue. Then we call gain underscore exp. I'm not entirely sure why display exp and gain exp are separate. I think it might be because when it shows the exp first before the golden items, but it doesn't want to show actor level ups until the item part is done. I think that's why, because level ups are the thing that comes last, so it's just separating them so that you can do the level ups as the last thing. So here we are looping through all members of the party, so that'll give you everybody that's in the party, including those who aren't participating in battles. Again, using iteration variable actor. We're just calling the actor's gain underscore exp method, passing in game troops exp total as the amount of experience to award them, and calling wait for message, and that will display level ups as part of this method, which we'll see when we get to look at game actor as a class. Finally, we call Scenemanager.return, and if you remember from looking at Scenemanager, that just pops off the stack and returns to that scene. And we're calling battle end with a result of 0, which, as you will recall, means that we won, and that's what we passed to event procs call. And then we return true because we did indeed win. However, if the game trip is not all dead, then we go here. So if aborting, which will be the case if we have aborted battle and set phase 2 aborting, which will cause this to return true, then we call process underscore abort. And we've already seen that because it's exactly the same method that's called if there's no party members. So the only use case I can think of for this is when you're running a game timer. When it runs out, it automatically aborts battle. Other than that, I cannot recall any other instances where this is used. And then we are returning false in any other case, because if we're not calling any of these, then the battle has neither been won nor lost. So we've, let's see, we've covered that, we've covered that, we've covered that, covered that, we've covered that, covered that. We have not covered process escape. So this process is an attempt to use the escape command, or a skill that causes escapes. So first of all, we add a game message using, for the formatted string, vocab escape start, which will display %s has started to escape using the game party's name. Oh, hey Zeke, no worries, man. Oh, I don't have my little chat widget. 1 second, let me just copy it from somewhere else. Stick that bad boy in here. Can I do that? Yes, apparently I can. Okay, if you say something now, it should hopefully show in this little black space over on the right below the cam feed. Had an impromptu meeting involving game dev stuff. Ooh, that sounds exciting. You've not missed a massive amount. I finished covering off Scenemanager. I've just been going through the Battle Manager and all of the methods that are available to that. So I've just gone through all of the different things that happen when the battle is aborted, if you're defeated or if you win. I'm just about to cover when you try to escape. So we're setting a temporary variable called success, and its value will be the result of this ternary if statement here. So if preemptive is true, meaning that the battle was a preemptive attack, then it just returns success is just set to true, because if you attack preemptively, you can always escape. It will always succeed. There is no chance involved. If it's not preemptive, then we're setting success to whether a random number from 0 to 1 is less than the escape ratio, which, as we saw earlier, is determined by the make escape ratio method, which sets that to the result of this little equation here. And that'll give you a percentage chance of being able to escape. We call the play escape method of the sound module, which, if we go back to here, just plays the system sound 8. And if you remember when I explained that 2 weeks ago in the database, under system, one, 2, 3, 4, 5, 6, 7. Yeah, so title screen is 0, battle is 1, battle end is 2, game over is 3, boat 4, ship 5, airship 6, cursor 7, escape 8. So it plays this sound effect here. If success is true, which it will be if either the battle is preemptive or the random number was less than the escape ratio, then we call process abort, which just aborts the battle, same as the other ones we've looked at. Otherwise, escape ratio is increased by 0.1. And what this means, and I don't think many people realize this, there's kind of a failure protection sort of thing in escaping, where every time you fail, it adds a 1% chance of success. So that gets added there. And then we're adding a game message with a 1/4 second wait, followed by vocab escape failure, which, if we look here, it says, however, it was unable to escape, which is very English in my opinion, and I would recommend changing that if you possibly can to something a bit more grammatically unclunky, but it does in a pinch for a default. And then we're calling game party's clear actions method, which just clears all of the party's actions. Quite simple, we'll see that when we get to it. Then we're calling wait for message, which waits for player input. 1% isn't 0.1, 10%. Oh, you're right enough. Sorry, man. Yeah, I can't math. It's adding 10%, not 1. It would be 0.01 if it were 1%. You're absolutely correct. Thank you for the correction. And we're calling wait for message, so that will wait for player input. And when you hit enter, it will return success, which will either be true if you escaped or false if you didn't. So we've done process support, done process defeat, we've done revive battle members, we've done battle end. So next up we have the self.input start method. So this starts the command input. If the phase is not equal to the symbol input, then we set it to that because that is the phase we want to be in right now. Then we call the make actions method of both game party and game troop, which will set up the action objects for all of our party members and all of our enemies. And then we call clear actor, which if we look back over here, just sets the actor index to -1 because we have gotten all of the because we don't currently have an inputting actor. That will be sorted elsewhere in a second. Where was I? So after that if statement, we return not surprise and game party inputable. So the logical and thing basically returns the left hand expression if it's truthy and the right hand otherwise. So if surprise is true, meaning that you were surprise attacked, negating that will set it to false, meaning that we will return this side of it. So it will check whether anybody in the party can input actions. If surprise was true, then negating it will mean false. Sorry, if surprise was false, then negating it will mean true. So it will return that side of it. After that, we have self.turn start. So this is called at the start of the turn. We set the phase to the symbol turn because that is the phase we currently want. We're calling clear actor to set the actor index to -1. We call game troops increase turn method, which just increments the turn number by 1. And then we call make action orders. So we're going to jump down to that. So for make action orders, we're setting the action battler's instance variable to an empty array. And then we're adding to it game party's members, unless surprise is true, meaning that the troop got a surprise attack on the party. If you were surprise attacked, the party doesn't get to act in the first turn, so that's why we're checking that before we add them. Same with this bit here, we're then adding the troop members to action battlers unless preemptive is true, in which case we won't do that. And then we're looping through each element of action battlers, and we're using as our iteration variable battler. And inside the block for that, we are calling the make speed method of each battler, which we'll see when we get to game_battler, I think the class is that defines that method. And then we call the sort method on action battlers. So when you see a method like this with an exclamation mark on the end, it's what's called a destructive method. What that means is it modifies the object it's being called on in place. So when we call sort with an exclamation mark, it is going to sort the actual array here. So whatever elements are in this, after this is done, will be in a different order. If you just called the non-destructive sort method, you would have to assign it to something because it gives you back a modified array that is a new object. So that's the difference between those. And the block that we're passing to this sort method, we're using two variables. A will be the current element and B will be the element after it. And we're returning whether the second element's speed, returning the second element's speed minus the first one's speed. So if the element after the current one is faster, it will end up being swapped with it. And if it's not, it will stay in the same place. And that will basically give us a sorted list of all the battlers in order of their speed. And obviously that means that the faster ones will be first. Where are we? Yes, so that was turn start. We've got the turn end method, so that is called when the turn ends. So we're setting phase to the symbol turn end. We're setting preemptive to false because preemptive only affects the first turn, and same with surprise because we only want these things to affect the first turn of battle. If we didn't do that, then the party that didn't get a preemptive or didn't get a surprise would just never ever get a turn, and that wouldn't be a very balanced battle system. So we've looked at display X, we've looked at gain gold, we've looked at that one, we've looked at gain X, we've looked at make action orders. Okay, so next up we have force action. This method takes as its parameter a battler object. So we're setting the action forced instance variable to this battler object that was passed to it. And then we're deleting that battler from action battlers. And the reason for that is if you're forcing a battler to take a particular action, you don't want them to also get a manual action. So if you force a party member to take an action, they don't get a turn in battle because obviously that would be a bit broken. We then have a method for checking whether there is an action being forced, and you can tell it's checking something because of this question mark. As I said 2 weeks ago when we looked at another method like this, this is just a naming convention. It doesn't actually mean anything in terms of the code itself. You don't need that question mark, but it helps us to denote when a method is checking whether something is true or not. And in this case, we are checking whether action forced is not equal to nil. So if it is nil, that will return false. And if it's not, meaning that it contains a battler, then it will return true because we are forcing an action. Then we have this method here, action forced battler, which gets us which battler is being subjected to a forced action. And that just returns the value of the action forced instance variable. Cool thing with Ruby is that if you just put an expression, then the last evaluated expression will be treated as the return value for any method. So you don't actually need that return statement. All you need is this, and the return will be considered implicit. And then we have a method for clearing the forcing of a battle action, and that just clear action force. That just sets the action force instance variable to a value of nil. And then last but not least, we have this next subject method. So we have an infinite loop, that's just loop do. So we're setting a temporary variable called battler to action battlers.shift. The shift method of the array class, which obviously this is part of because it is an array, it's the opposite of pop, basically. It takes the first element of the array, removes it from the array, and returns it. So this is basically taking the fastest battler, the one from the beginning of the action order list, and putting in this variable here. We return nil unless there is a battler. So if there is one, then this won't happen. If there isn't, then we return nil because we don't have a battler to do anything with. That means that the array is now empty. Then we're doing next, unless battler.index returns a truthy value and the battler is alive. So just to explain that in a bit more detail, next goes to the next iteration of the loop. And we will do that unless the battler has an index, and we'll see when we get to the battler what the index method does, but basically it will either return a value or it won't. And the alive method checks to see whether the battler is alive or whether they are dead or not. So we want to keep this battler if they have an index and are alive. If they're not, we don't, so we go to the next one, and then we return the battler. So this being an infinite loop might seem like a bad idea, but every part of this will eventually return something that gets us out of the loop. So it's not really an infinite loop as such. It's just kind of the outer one is, but we ensure inside it that there is always an exit clause to get out of it. So that is all the modules. That gets us into the game objects, starting with game_temp. Game temp handles temporary data that will not be saved in a save game. And the instance of that class is referenced by $game_temp. And we can verify that if you go back to Data Manager, where we have the create game objects, you can see that this object here is assigned a new instance of the game temp class. So we can then refer to that anywhere in the code because the $sign denotes it as a global variable that can be accessed by anything anywhere. And that is a requirement of Ruby. If you're making a global variable, it has to have that $sign. That is a syntactic thing. It's not a naming convention. So we're declaring a couple of public instance variables. So we've got this comment event ID, which is an ATTR reader. That means that we can only read its value. We cannot write to it. And then we have an attr accessor called fade type, and that can be read or written to. And so comment event ID will store the ID of a common event. So if we go into the database to the common events tab, this will correspond to the number on the left hand side. So that's ID1, ID2, ID3, etc., etc. And fade type is what fade type you have chosen when you transfer the player. And as we will see, that is determined by I don't actually think this is visible on my thingy, but when you're doing a transfer player thing, you get an option for fade. You get normal, white, or none. So that will just be, that corresponds to those values. So we have this initialize method, and the initialize method of a class is called whenever a new one is created. So in Data Manager, when we have this gametemp.new, that automatically calls the initialize method. It's called a constructor. If you don't provide one when you create a class, there is a very bare bones one that Ruby provides for you that doesn't actually do anything, but just ensures that there is a constructor that can be called, so that you don't get an error saying that there isn't one. But here we are providing a constructor for the class, and what we're doing is we're setting the instance variables. So we're setting common event ID to 0 and fade type to 0. So that just initializes these with their default values. We have a reserve common event method, and that takes as its parameter a common event ID, and all that does is sets the instance variable common event ID to the passed in value. So if we call reserve common event 2, then the instance variable common event ID would be set to 2. Then we have a method to clear common event call reservation, just called clear common event, and that sets the common event ID to 0. We have a method for checking whether a common event is reserved, funnily enough called common event reserved ? And that checks whether the common event ID instance variable has a value greater than 0. So if it's 0, meaning it's been initialized, that will return false. And if we have reserved a common event, then it will have a value greater than 0, and that will return true. And then we have a method for getting the reserved common event, and that returns the member of the data common events array with an index corresponding to the common event ID. Now we can see here that data common events is assigned the value from load data using, oh wait, that's the battle test, this one here, using data common events.rv data2. Now this is a data file that is written to whenever you apply changes to the database. So if I called this, for example, test and then applied, that is writing to that rv2 data2 file. And this is the data that it's using to populate that file. In RPG Maker MV and MZ, it's the equivalent of the JSON data files. I don't know how RV-data2 files are stored. We don't have any method of directly editing them or seeing their contents. If you open one up, you'll just see gibberish. And as far as I know, nobody's written a parser for one. It will contain basically a reference to all of these event IDs and what their names are, what the triggers are, the condition switches, and their contents. And that can be referred to by getting this object here. And we can then use that to get any of the stuff that was set in it, like the list of event commands and whatnot. And that's it for GameTemp. It is a very small class. One thing that quite a few script developers in the community used to do was if they were adding new stuff that wasn't in their scripts that wasn't going to be saved, they would just kind of extend GameTemp. Then we've got Game System. This class handles a system data, saves things like the disabled state of saving and menus and things like that. An instance of this class is referenced by Game System. If we go back to Data Manager into the Create Game Objects, we can see that there. Game System is being assigned a new instance of the Game System class. So we have quite a few more public instance variables than we did in GameTemp. So we have an attr accessor called saveDisabled. This is a boolean, it will either be true or false, denoting whether we can save or whether we cannot. And it's an attr accessor, so you can read its value or you can write it. We have another attr accessor for menu disabled, just the same thing but for the menu. Attr accessor called encounter disabled, same thing but for battling, basically. An attr accessor called formation disabled. That denotes whether the player can change their party formation or not. So I'll just kind of demonstrate that. So if we go to the System tab, I don't think you can actually set it in there, but there is an event command called page 3, change formation access. So you can either disable or enable it. So if I put that in this guy here and then go into test play. So when I'm in the menu here, I can do the formation command and I can change the order of party members. Then if I talk to this guy who had the event command for disabling formation, note that I cannot access it anymore. And that is basically because of this flag here. Then we've got an attr accessor called battle count. That is just an integer value that tracks how many battles the player has fought since starting the game. We have an attr reader called save count. Now you notice a reader rather than an accessor. You can read it, but you cannot write to it. So we can get the save count, we cannot do anything to change it. If you tried to do game system dot save count plus equals 1, you would get an error because it is not. In fact, I'll show you. So as you can see, we've got the $sign game system global object. If I get rid of that, I'll just go and do a script command. So do game. I know you can't see this, but you'll see it in a second. So game system dot battle count plus equals 1. Game system dot save count plus equals 1. So you can see there I've got these 2 lines of Ruby code in the event. Now if I go into test play, talk to the guy, I get an error here because there is an undefined method save count equals for game system, and that is because it is a reader and not an accessor or a writer. So that kind of leads me nicely into something about this. So when you define a variable as an attr accessor, what Ruby is doing behind the scenes for you is it is writing both a read method and a write method. So effectively what that's doing is so when we define this as an attr accessor, behind the scenes it's creating these methods for us. So it gives us a reader method with the same name as the property, or the variable, which just returns the variable's value, and it's giving us a writer method, so that's just the name of the variable equals, and then the parameter here. Now the parameter doesn't have to have the same name, but it will do in the one that is written, just because that's how it works, and it sets the variable to that value, and that is how attr accessors work. If it's an attr reader, we only get this one, and if it's an attr writer, we only get this one. There you go, you've learned something today. Yeah, so that was formation save count. And then we have another attr reader called version ID, and that stores the version ID of the game, which we can read but cannot write to. Okay, so we have our object initialization, the constructor for the class. So here we're just initializing all of the instance variables to their default values. So save disabled will be false because the player can save, menu disabled will be false because the player can access the menu, encounter disabled will be false because you can get into battles, formation disabled will be false because you can switch to party order, battle count is set to 0 because we haven't had any battles yet, save count is set to 0 because we haven't saved any games yet, version ID is set to 0, the window tone, you'll note there that that isn't a public variable because this will only be used by this class, but window tone is set to 0, battle BGM is set to 0, battle end ME is set to 0, and saved BGM is set to 0. So window tone is an object that will store a tone object, which denotes what tone the game window will have. And I do believe that it is modified by this window color bit here in the system tab of the database. So when you double click that, you get to pick the red, green and blue components of the tone. Battle BGM will contain the audio file that is played when a battle happens. Same Battle End ME, that is basically the victory theme, and saved BGM will contain an audio file that has been saved. So then we have a method called Japanese ? Returns data system.Japanese. This isn't something that you can set in the database or anything like that. It just determines if your locale settings are set for Japanese mode, which being mainly English speakers, I don't imagine ours will. But if you're in Japan, yep, probably. So then we've got a getter method for window tone. That gives us either the value of window underscore tone if it's truthy, which it will be if it's not nil, but to begin with it is. If it's not, then it will return this value here, which is the window tone from data system. And that is the tone value that I just showed you in the database. Then we have window tone equals. So see here, we've got the getter and the setter, and if we didn't have this bit here, we could have just made this an attr accessor because it would have done this for us. But because we need to do more with the getter than an attr accessor would provide for us, we do need to do it manually. So we've got a setter here for window tone, just takes window tone as a parameter and sets the value of that instance variable to the value passed in. We have a getter and setter for Battle BGM as well. It's exactly the same principle. So the getter will return either the value of the instance variable, or if that's nil, it will return the value from the database, and data system battle underscore BGM will end up being this value here. I'm not sure if it actually shows when I highlight things, which is a bit annoying. Yeah, the battle bit there in the music section is the one that I'm talking about. Then we've got a getter and a setter for battle and ME, just the same principle. Getter gets either the instance variable value or the value from the system tab of the database. The setter just takes an audio object and sets the variable to that value. So next up we have an on before save method. This is we call them event methods because they're called in response to something happening, but really they could be called anything and they're called just the same as any other method is. But this does pre-save processing, as it says in the comment. So we add 1 to the save count variable. Now note that we can do that here because this variable it belongs to instances of this class. So the class itself is fine to modify this value. It can do anything it wants with it. But anything outside of it, because we haven't defined it as an attr writer, can only read it. We can only get its value. So we add 1 to that because we are adding 1 additional save. We set the version ID to the version ID method from data property from data system. As far as I am aware, this is randomly generated each time the game is saved. Let me just double check the help file. Yes, it's a random number used for update checks, and the number changes every time data is saved in the editor. We set the frames on save instance variable to graphics.frameCount. We cannot see the exposure of the graphics module in the script editor, but frame count just gives us the number of frames that have elapsed since the game started. So we're basically, saving how many frames had elapsed when the game was saved. We're setting the BGM on save to the last playing BGM and the BGS on save to the same for BGS, and that means that when we save the game, it remembers what music and sound effects, background sounds were playing. Because if we didn't do that, then when we loaded the game, the music wouldn't be able to reinstate itself because it wouldn't know what music to play. We then have on after load, which is kind of the same thing but for post load processing. So here we set graphics.frameCount to the value of frames on save. That will be populated when the game loads, and you can see that in Data Manager, I believe. So when we did the extract save contents, so we set game system to the system contents of the save file, and that will have the values that were in there when it was saved. So that will contain the number of frames that had elapsed when the game was saved, and then we set the frame count to that so that the number of frames that have elapsed is set to what it was when you saved the game. If you didn't do that, then it would just initialize as 0, and every time you saved the game, you would lose your frame count, and that buggers up things like timers and things of that nature. And then we call the play method of both the save BGM and the save BGS, and that starts the music playing again. Then we have a playtime method, and that takes the graphics.frame count divided by graphics.frame rate. Now, unless I am mistaken, and I'll just double check the help file here for it. Frame rate is the number of times the screen is refreshed per second. It's normally set at 60. You can change it. It can just be set anywhere from 10 to 120, but this is not generally recommended because a lot of things are kind of predicated on a 60 frames per second frame rate. But anyway, assuming that is 60, then you'll get the frame count divided by 60, and that will give you the number of seconds that you have been playing. Then this method here gets the playtime as a character string. So we set a temporary variable called hour to the result of calling playtime divided by 60 divided by 60. Reason for that being, if you've got the playtime in seconds, you divide by 60 to get minutes, you divide by 60 to get hours. Then you have minutes, which is playtime divided by 60 mod 60. So you divide by 60 to get the total number of minutes, and then you mod 60 to remove the number of hours from that. So that only gives you the number of minutes past the hour. And then sex to playtime mod 60. So it divides the playtime by 60, returns the remainder, and that gives you the number of seconds past the minute past the hour. And then we've got our trusty old sprintf formatted string. And here, instead of %s, we have a %02d. So that's a 2-digit precision number. So we've got a 2-digit precision number, colon, 2-digit precision number, colon, 2-digit precision number. And into those placeholders, we are passing our min and sec, and that will just give us the time as it would appear in the menu. And I'll kind of show you in test play there. Oh no, wait, there is no timer on the thing in VXS. Forgot about that. But yeah, it'll just give you the display as it would be on a digital clock, basically. And the 02 means that if it's a single digit, it will be prefaced with a 0. So that's how you get like 0000005 for when you've been playing for 5 seconds, for example. And then we have a save BGM method, which just sets the saved BGM instance variable to the last playing BGM, background music, and replay BGM, which calls the replay method of save BGM if one does exist. And that is it for game system. Then we have game timer. So this class handles timers. Instances of that class are referenced by the global game timer object. So I'll just quickly show you what the timer controls. So start one for 2 minutes. Go into test play. So you can see at the top right there, it started a timer counting down from 2 minutes. And that is the where game timer handles all that stuff, except the sprite, which we'll come to later. So in our initialize method, our constructor for the game timer class, we are setting the instance variable count to 0. Note that it is not an attr reader, attr writer, or attr accessor, because nothing else outside this needs to access it. And we set an instance variable called working to false. So that will be a Boolean value that determines whether the timer is currently running. We have our frame update method, so def update. Due to the way the engine is set up, all you have to do for a class to update every frame is to give it an update method. You do not need to specify the calling of it. I don't think, actually, do you? I might be thinking of Windows. Yeah, sorry, you do actually need to call it, but it's a naming convention for any method where you will be updating every frame. So if the working flag is true and the count variable has a value greater than 0, then we decrement count by 1, and then if the count is equal to 0, we call the onExpire method. And onExpire at the moment just calls battlemanager.abort. And what that does is if the timer reaches 0, then we call the abort method of battlemanager. Which, as you may or may not remember, sets the phase to aborting, which means that this line here will return true, which means it will call process abort, which means it will get out of the battle. So if the timer runs out, the battle will end. And that's how that works. We have a start method, and it takes as a parameter a count, and that will be in seconds. No, it won't. It will be in frames, sorry. So the count instance variable's value is set to the value passed in, and we set the working flag to true because now the timer has started. We have a stop method which just sets working to false. It doesn't do anything about the count, so you can stop a timer and then restart it and it will resume from where it was. We have a working method with a question mark, so that tells us that we're checking something and we're checking whether it is working or not, and it just returns the value of this flag. So that will be true if the timer is running, false if it's not. Then we have a sec method which gets the number of seconds that are on the timer, so that gets the count value divided by the graphics.frame rate, which again by default is 60, so it'll be count divided by 60, or whatever you change that to if you're doing less than or greater than 60 frames per second. And then we've looked at onExpire, and that's basically all there is to the functionality of a timer. Very, very simple. So then we have game message. Now this class handles the state of the message window that displays text and selections and whatnot, and instances of that class are referred to by the global game message option object. So if I do a show text and show some choices, so when I go up to this guy and he says this in text and I get the option of yes or no there, this part is handled by the game message class. So we have several public instance variables here. We've got an attr reader called texts, and that is the text array where each element is a row of text that you want to display. Note that because it's an attr reader, you cannot modify it outside of this class. We've got an attr reader called choices, which is the choice array. We have an attr accessor called face_name, and that is the file name of the face graphic that will be used in the message window. So if I go back into this thing here and I add a face graphic to it, and I talk to my dude again, you can see there that there's a face in the message window, and that is stored in the name, file name of it is stored in that. Then we have another attr accessor, face index. That is the graphic index of the face set. Face graphics are stored in 8s, so each graphic has 8 different faces on it. They are indexed from 0 to 8, going from left to right, top to bottom. We have an attr accessor called background, which stores the background type, which will either be normal, window, or window, dim, or none. Window being what you saw there with the visible window. Dim will just have a partially transparent black background, and none will have no background at all. We have another attr accessor called position, which will store the display position, which will be top, middle, or bottom. We have an attr accessor called choice proc. That is a callback for the show choices. We'll come to that later on when we get into scene message. Don't believe anything is done with it right now, which is fine. Procs are slightly complicated to explain, but we'll get there. We've got an attr accessor called choice cancel type. That will store the cancel option. So when you're doing a show choices command, you can choose which option will cancel it, or whether there is a way to cancel it at all. Some of them don't have a, or is there an option for none? When cancel, yeah, you can disallow cancelling, so you have to choose an option. You've got an attr accessor called num input variable ID, and that is the ID number of the variable into which number input will be stored. So when the player inputs a number, it's always stored in a variable, and that stores the ID of that variable. We've got an attr accessor called num input digits max, and that is the maximum number of digits that can be input in a number input box. We've got another attr accessor, the item choice variable ID, and that is the ID of the variable that will be used in the select item event command, which just allows you to select an item from your inventory and stores its ID in the denoted variable. We've got an attr accessor called scroll mode that determines whether we are currently scrolling text or whether the text is static. We have an attr accessor scroll speed, and that determines the speed of scrolling text. We've got an attr accessor called scroll no fast, which is a true or false boolean, denoting whether we have disabled fast forward or not. If fast forward is not disabled when text is scrolling, you can use the enter key and it will scroll faster. And we have an attr accessor visible, which determines whether we are currently displaying a message or not. So our constructor is fairly simple. The initialize, we call the clear method, and then set visible to false, because we're not currently showing a message. And then the clear method is just this one here, so we're initializing all of our instance variables. We're setting texts to an empty array. We're setting choices to an empty array. We're setting the face name to a blank string. We're setting the face index to 0, the background to 0, which will be window by default, the position to 2, which will be bottom by default, choice cancel type to 0, which is, I believe, disallow, choice proc to nil, the num input variable ID to 0, num input digits max to 0, item choice variable ID to 0, scroll mode is false because we're not currently scrolling text, scroll speed is set to 2, and scroll no fast is set to false because we have not yet disabled fast forward. Then we have the add method, which takes as its parameter the text to add and just pushes that text to the texts array. As we've covered previously, push is a method that adds an element to an array. So that just takes whatever text you've passed it and adds it to the array as a new element. So you may remember from Battle Manager, we've got things like this in process victory where we do game message.add, and then this is what gets put into the text parameter as its argument, and then that's what gets pushed into the text array, and that's how we get game messages. We have a method called hasText question mark, which determines the existence of text. Checks whether the size of the text's array is greater than 0. That'll be false if it's a blank array and true if it has anything in it. We have a choice question mark method which determines whether we're in choice mode, and that returns true if the size of the choices array is greater than 0 and false otherwise. We can also determine if we're in number input mode. That's the num input question mark method. And we determine that by checking whether the num input variable ID variable has a value greater than 0, which it will be false if it's not in number input mode, and true if it is, because when we go into number input mode, we will set that to the variable that was selected in the event command. We do the same thing for item choice question mark, just checks whether the item choice variable ID is greater than 0. We have a busy question mark method determining if the thing is currently busy. So that calls has text. Now, if that is truthy, then that will just return that value. If it's falsy, it will then go to choice. If choice returns true, then it will just return true, and if it's false, it will then go to num input. If num input returns true, then it will return that. If not, it will go to item choice, and so on and so forth. So yeah, when you've got a logical OR, I know I've explained this before, but I'm just going to reiterate it again. If the value of the left-hand side is truthy, then it just returns it. If it's falsy, it returns the right-hand side. But the right-hand side here is this. And then that's the left-hand side of that main part. So if it's true, it's that, and if it's falsy, it'll do this, and so on and so forth. And that's how you do kind of compound ORs. Ampersands is the opposite. That's if the value is falsy, then it will return false. Otherwise, it will move on to the next one, and so on and so forth. So in that we can say that the message is busy if there is text, or if there is a choice being made, or if the user is entering number input, or if the user is selecting an item. Mainly because you can do these without having text displaying, so you need to check all of them. We then have a method called new_page that creates a new page in the message window. So we are setting the -1 index of the text's array. We're adding to it, we're adding a line feed if text.size is greater than 0. So in Ruby, you can access array elements using a negative index, and what that does is it works backwards from the end. So this is the equivalent of basically adding this to the last element that's in the array, which means that there will be a new line at the end of it. So that's that. Then we have a method for getting all text, which will include new lines. So this involves a method called inject, which is a really nice method on arrays. I believe it's the equivalent of the reduce method in JavaScript. Let me just double check that I am right on that. Or does Ruby have reduce? Yeah, inject and reduce are aliases. There's no performance element to using either of them. They do the same thing. That is what I thought. So basically what we're doing is we're starting with a blank string. So inject takes an initial value as its parameter, and then we're passing this block to the initial value. And it's basically going to loop through each element of the array passed to it. Strings are considered arrays. So this will basically just be a 0-element array. And we're using 2 iteration variables. So R is what's called an accumulator, where it will hold the accumulated value of all of the elements that have been looped through so far, and text holds the current element. and then we're setting the accumulator. We're adding text to it, followed by a new line character. And that will give us all of the text lines separated by new line characters. And that is that. And that's it for game message. Again, it's quite a compact class. A lot of the heavy lifting there is done by the message window and the stuff in the scenes that involve messages, but we'll see that when we get to it. So next up we have game switches. This class handles switches. It's a wrapper for the built-in array class. And the instance of that class is referenced by the global game switches object. So a switch in RPG Maker is just a handy way to give the game developer a way to have a value that can either be true or false, on or off. It's like a light switch, effectively. A light switch, unless it's got a dimmer, is either on or it's off. If it's on, the light is illuminated. If it's off, the light is not. And this gives the developer the ability to have certain things in the game happen or not happen depending on something being true or not true. So that is basically what switches do. So the game switches class just contains information on all of the game switches in your game, and when it's initialized, we're setting an instance variable called data to a blank array. It is of indeterminate size. Good thing about arrays in Ruby is that they do not have to be dimensioned with a particular size. You can just add to them as you need to, and they will resize themselves to accommodate that. So we have a method here for getting a particular switch. So we can see here that the def has the open and closing square brackets, and then the brackets here, parentheses even, and then it takes switch ID as a parameter. And that allows you to do that. So this is, again, something that you can only really do with Ruby. JavaScript can't really do stuff like this. It's a very syntactic, sugary sort of thing with Ruby that I really like. When you define a method using the array index notation, it means that you can access something directly by just calling that, rather than having to do, for instance, that, which would actually crash in this case because data is not a property that we can access due to it not being an utter accessor or utter reader. So here we are returning either the element of data at an index of the switch ID, and if that returns a truthy value, then it will just return that. If it returns a falsy value, then we hop over to the right hand side and just return false. So if we provide, say, if we do now, before we have set that to anything, it will not be in the data. Something that you may not realize about switches is they do not exist in this array until we reference them. So that will just immediately reference false because switches are off by default. But then we have the setter method here, which just uses kind of the same notation, but you notice as well as the array indexing brackets, we've got an equals here, which shows us that we can do that, for example. Oh, sorry. Yeah, that's right. So it takes two parameters, the switch ID and a value. And even though this looks like an assignment, it is actually calling the method. It's the way Ruby's equals methods work. This is basically calling that method, passing in this value here for the switch ID and this value for the value. And then we are setting the switch ID index of the data object to the value passed in, and that initializes it in the array, and then we call on_change. You can see here that that just processes when we're setting switches, and it sets the need refresh Boolean property of game map to true. And as we'll see when we get to the game map class, that basically refreshes any events that are dependent on the switches being a particular value or not. So that is game switches. Then we have game variables. This class handles variables. It's again a wrapper for the built-in array class. The instance of this class is referenced by the global game_variables object. Now, variables are much in such the same as switches, but instead of being on or off, true or false, they can hold any numeric value. That's not necessarily true. They can actually hold anything, but when you're going through the RPG Maker UI, they can only hold numbers, unless you use the script setting for them, but that's neither here nor there. So again, in the initialize, we're setting the data to a blank array. The getter method here returns either the data at that index or 0, rather than false, because this is a value, numeric value rather than a true or false. Everything else is just the same. It's just that instead of giving it a Boolean value, you're sending a numeric value to it. I believe self switches were new to. Did XP have self switches? I can't remember. Anyway, self switches are basically switches that are unique to an event. So each event in your game has 4 of them. You can see here you can use A, B, C, or D. That's also not strictly true. Excuse me. In code, you can set any self switch you want. You can define multiple letters if you want to. But again, just using the UI and nothing else, that is how that works. You only get the 4. So this is a wrapper for the built-in hash class, and the instance of that class is referenced by $game_self_switches. A hash is kind of like an array, only instead of a single index to reference it, you reference it by a multi-element key, which can be numbers or strings or a combination of the two. I think you can use symbols as keys as well. And here we are still setting the data in the initialize, but you'll notice here we're using curly brackets rather than square brackets. And that is because that is how you dimension a new hash rather than a new array. I think it was VX or ACE that started self switches. I did think that, but I couldn't remember. I'm pretty sure it was VX in that case. So we've got a getter for self switches here. So you've got your, it's still array index notation, but you're providing a key rather than an index, and then checking whether the element in the hash corresponding to that key is equal to true. So that will either return true if it's true or false if it's not. So using that, you can do something like game self switches 1 to A. So just to clarify there, the key that's used for a self switch, just because of the way the engine is designed, is that there's 3 elements to it: the map ID, the event ID, and the self switch letter. So this would correspond to the self switch A for event 2 on map 1. and when we pass that key to it, it will check to see if that key in data is true, and if it exists, it will either be true if it's been set to true, or false if it's been set to false. If it doesn't exist, it will just be false because it doesn't exist. So then to set a self switch, we have the same notation as we used for switches and variables. Instead of an index, you have or an ID, you have a key, and also the value there. And then it sets that key of data to be this. And then it calls onChange, which, as with the other ones, just sets GameMap.needRefresh to true. And that's it for game self switches. So that takes us to game screen. This, as the comment says, handles screen maintenance data. Okay, I was wrong. XP had self switches, it would appear. Okay, yeah, so 2K3 didn't have them, XP did. Yeah. I haven't. The last time I used XP was for doing the script that I was telling you about for it for my Patreon guy, so I couldn't actually remember whether they had them or not. Yeah, so this class handles screen maintenance data such as changes in the color tone, flashes, etc., and it's used within the game map and game troop classes. So we've got a number of public instance variables here. They're all attr readers, so we can only read them, we cannot write to them. So we've got one called brightness, so that will be the screen, well, brightness. We've got a reader for the color tone. We've got one for the flash color. We've got one for the pictures. I believe in VXACE you can have up to 20 pictures on screen at once. Oh no, it's 100, sorry. It was 20 in 2K3 XP. One of the previous ones at 20. But you can have 100 in VXACE, so that's happy days. The shake positioning, we've got a reader for that, we've got a reader for the weather type, and a reader for the weather power. You have built-in weather in VXACE, and you can call various weather effects, and these are controlled by these variables here. So pretty simple constructor here, our initialize method. All we're doing is setting the value of the pictures instance variable to a new instance of the game_pictures class, which we'll see 2 things from now, but that'll probably be 2 weeks from now. And then we're calling the clear method. And the clear method just calls clear fade, clear tone, clear flash, clear shake, clear weather, and clear pictures. Clear fade sets the brightness to 255 and fade out and fade in duration both to 0. You'll note that these haven't been referenced yet because these are not used outside of the class, but they are the duration in frames for a screen fade out or in. Clear tone sets the tone to a new instance of the tone class. You can look that up in the help file for information on it. It's not exposed in the script editor, so you can't really see its implementation. We're setting an instance variable called tone_target to a new instance of the tone class and a tone duration to 0. Clear flash is setting flash color to a new instance of the color class and the flash duration to 0. Clear shake is just setting the shake power to 0, the shake speed to 0, the shake duration to 0, the shake direction to 1, and shake to 0. Shake is the shake positioning. Clear weather sets the weather type to the symbol none. Weather power to 0, the weather power target to 0, and the weather duration to 0. And clear pictures, just loops through each element of the pictures object, which will be an array because that's what pictures is, as we'll see. Goes through each element of that using the iteration variable picture and calls its erase method, which removes it from the screen. And that is that for the initialization. So game screen has a start fade out method, and that takes as its parameter a duration in frames, and that just sets the instance variable fade out underscore duration to the number passed in, and the fade in duration to 0. Reason being, obviously, if you're fading the screen out, you don't want to be fading it in, because you cannot do both of those things at once. And start fade in is just the opposite. We're taking a duration, we're setting fade in duration to that number and setting fade out duration to 0 because we don't want to be fading out the screen when we're fading it in. We have a method for starting a tone change. So that takes as its parameters a tone and a duration. So we're setting the instance variable tone target to a clone of the passed in tone object. We're setting the tone duration instance variable to the passed in duration in frames. And then we're setting the tone instance variable, which kind of keeps track of the actual screen tone, to a clone of the tone target if tone duration is equal to 0. Which basically means that if it's a duration of 0, that's an instant tone change. It just changes the tone immediately rather than having to move towards a target. We have a start flash method, which takes a color and duration as its parameters. So we're setting flash color to a clone of the color, and a flash duration, the flash duration instance variable to the duration passed in frames. We've got a start shake method, which takes 3 parameters: power, the intensity of the shake, from I believe 1 to 9, speed of the shake, again from 1 to 9, and a duration in frames. So we're setting shake power to the power, shake speed to the speed, and shake duration to the duration. You'll note there that shake direction and shake are not used there. That's because these are used to control, they're referenced elsewhere in the update shake, which we'll see shortly. The change weather method is used to, well, change the weather. So we take as parameters here a type, which you can see there will either be the symbol none, the symbol rain, the symbol storm, or the symbol snow. The power, which is the intensity from 1 to 9, and the duration in frames. And set here, if weather type is none, we set the weather power target, the target value of intensity, to 0 to represent gradual stopping of rain, but only in this case. And you can see there that that is being done in the code there. So we're setting weather type to the passed in type if the type is not equal to none, or it's none and the duration is 0. Then we set the weather power target to either 0.0 if the type is none, or the power converted to a floating point number if it is not. So if it's rain, storm, or snow. We set the weather duration variable to the duration passed in, and then we set, as we did with the tone here, if the duration is 0, meaning an instant change, we're just setting weather power to the power target immediately. So then we have our frame update method. So here we are calling update fade out, update fade in, update tone, update flash, update shake, update weather, and update pictures. Our update fade out, if the fade out duration is greater than 0, meaning we still have frames to go before the fade out is done, we set a temporary variable d to the value of that fade out duration. And then we set the brightness instance variable to the result of multiplying brightness by 1 d minus 1 and then dividing that by d. And that will basically give us the tweened out brightness between what it started out as, what it's heading towards, based on how many frames are left. And then we decrement fade out duration by 1. Update fade in is much and such the same thing, only we're using fade in duration instead of fade out, and we're using d-1 plus 255 for the thing because we want the brightness to go from 0 to 255, or from whatever it started as to 255. So we need to add that on so that this gives us the proper tween value. Then update tone is more or less the same thing, only we're doing the individual red, green, blue and grey aspects of the tone and adding on what the target components are before we divide by the duration. Update flash, pretty much the same thing, only for the flash colors alpha property, which is how transparent it is or isn't. And then update shake is a little bit more complex. So if the shake duration is greater than 0, or the shake variable has a value that is not equal to 0, then we're setting a temporary variable called delta to the result of multiplying together the shake power, the shake speed, and the shake direction, which, as you'll see when it starts out, is 1, divided by 10. If the shake duration is less than or equal to 1, meaning it's got 1 or fewer frames remaining, and the value of the shake variable multiplied by that value plus the delta is less than 0, then we set shake to 0, and otherwise we add delta to it. This is basically how it gets a semi-random shaking effect. It's just kind of getting the delta position of where the shake is currently at. So we set the shake direction to -1 if the value of shake is greater than double the shake power. We set it to 1 if the value of shake is less than the negative of shake power times 2, and otherwise we just subtract 1 from shake duration. Then to update the weather, if the weather duration is greater than 0, we set the d to the weather duration. In fact, that is more or less just the same as the other ones, so there's not really much point in going further into it. If the weather duration is equal to 0 and the weather power target is equal to 0, then weather type is set to none because we have ran out of weather, basically. So for update pictures, we are going through each picture in the pictures array using the iteration variable picture, and in the block for that we're just calling each picture's update method. And then we have our start flash for damage method, which is used for the poison effect or damaging floors. That calls start flash, which will, as you may recall, is here. We need to pass in a color and a duration. And for the color, we're passing in a new instance of the color class with 255 as the red component, 0 as the green component, 0 as the blue component, and 128 as the alpha or transparency. This gives us a basically half transparent red, and 8 for the duration because the flash from damaging floors lasts for 8 frames. And that is it for game screen. So that is now just past 9. I've been on for a bit over 2 hours, so I am going to leave it there for tonight. So it just remains for me to say thank you, Siegfried, and anybody else who happened to be on the stream with me. As most of the people from the community who know me will know, I do offer a lot of RPG Maker related services. I do coding commissions. I quite often help out on Discord and the forums. I have one-on-one coding tutoring available on my Patreon, which well, I'm just going to link Patreon in general, which helps nobody. Then I'll link my Patreon, which helps me. So I've got a few tiers there that might be worth looking at. I do written feedback on games, offer one-on-one tutoring. I can do debug sessions once a month. There's various different things there that I do for the community at large. But other than that, thanks very much for joining me. I will be back on Friday for the next installment of Rise of the Third Power. So please do tune in for that. It's a bit less of a dry subject. It's me playing a game rather than explaining how code works. And yeah, thanks very much, and I will see you next time.